Hello. Get out of here. Okay. Hello, Marauders. Okay, hopefully you did pretty good with the angles yesterday. We're going to do a little fancier today. We're going to deal with a few more shapes and throw a little algebra in there and give you some stuff to try. Okay, so we learned yesterday every triangle is 180. Okay, but what if you had a quadrilateral? What if you had 4 sides? Could be a square, a rectangle, rhombus, parallelogram, kite. Well, I know this is 180, but what about this? Well, a lot of you know if you had a rectangle, these would all be 90. In fact, all 4 of these would be 90. Well, 90 plus 90 plus 90 plus 90 is 360 degrees. But there's a way to prove that. And this will work because what if you want to do the pentagon? Well, imagine you had a sandwich. You ever cut your sandwich diagonally? Just like that? If you cut it diagonally, don't you have 2 triangles? Like if you cut your peanut butter and jelly sandwich? Well, if that's a triangle, and a triangle is 180, and this is a triangle, that's 180. 180 plus 180 is 360. This is an interesting information because now I have to do a pentagon. What are all these angles? I'm not sure. But wait a minute. How about I cut it up into triangles? Pick any corner. You could pick this one. This one's already side. Just go straight across. That's called a diagonal. Now do the next one. And well, I guess that's it. So I started just one corner or one vertex. Draw triangles. I have a triangle. I have another triangle. I have another triangle. These are all degrees. 180 plus 180 plus 180 is 540. I can use that to do a hexagon and an octagon no matter how many sides. In fact, some people realize the clue. Count the number of sides, subtract 2, and times by 180, and you'll get the total of the angles. Really? Yeah, let's see. 5 sides. What is 5 minus 2? 5 minus 2 is 3. 3 times 180. It works here. Sides. 4 sides minus 2 times 180. 4 minus 2 is 2. 2 times 180, 360. Even here, 3 sides minus 2 is 1. 1 times 180. So I could even do it if somebody gave me an octagon, which is 8 sides. Like 8 sides. 1, 2, 3, 4, 5, 6, 7, 8. It doesn't have to be perfect. But I could go, let's see, 8 sides minus 2 is 6. 6 times 180, and I could use a calculator, but that's 1,080 degrees. If you add up all 8 of these angles, it's 1,080 degrees. So let's look at this for a moment. Okay. Sometimes these shapes are perfect. If they're perfect, we say they're regular. Regular means all the sides and angles are the same. So if we had a triangle and I said it's regular, equilateral, could you actually figure out each angle? We see 180. If somebody says it's regular, these are all the same. 180 divided by 3 is 60. So each angle is 60. Could I do it over here? Sure. We got 4. If somebody says it's regular, so in other words, everything's the same, I should have made it more like a square, then I could just go, okay, 360 divided by 4, each angle would be 90, which makes sense. But what about a pentagon? Do you know each angle in the pentagon? Well, if somebody says it's regular, then every angle here is exactly the same. We said we have 540 degrees. Well, if there's 1, 2, 3, 4, 5, we could divide it by 5, and that's 108. Each angle is 108 degrees. So I could do that. What about the octagon then? Do you know what each angle is? Let's see. There's 1, 2, 3, 4, 5, 6, 7, 8. Divide by 8. I put that maybe in a calculator. I get 135 degrees. Okay, there is more stuff to it, like figuring out the exterior angles and stuff, but we're just trying to do what we can in a little bit of time. So there's some shapes, and sometimes the shapes aren't perfect where you can just cut it up evenly. Okay, so let's look at these shapes. Once again, even if the polygon is not regular, the sum of the angles is still the same. I see 1, 2, 3, 4. So I go 4, that's 360 degrees. But I can't divide by 4, but ooh, there's 90, and here's 90, and here's 60. So I could go 90 plus 90 plus 60 and subtract from 360. and get this answer. I probably the L. And of course, after I subtract all that, x over here, I'll use red, would be 120 degrees. And it looks like 120. Doesn't it look obtuse or big? Likewise here, this plus this plus this plus this has to be 360. I could go, let's see, 140, 60, 90. This is a 90. And I add it up. That's 290 so far. If I subtract that from 360, my leftover piece is 70. So I could figure that out. And what about over here? How many angles do we have? We've got, let's see, 1, 2, 3, 4, 5. Oh, this is a pentagon, right? Pentagon, and a pentagon was 540 degrees. If you forget, you can go, let's see. That's 1, 2, 3 triangles. 3 times 180, 540. But they're not all the same. So I could take my calculator and kind of go, okay, well, this plus this plus this plus this, which I don't know, plus this adds up to 540, and then get a calculator out, and I could figure out the missing angle. You might say, it looks like 90. Well, might be 91. You're not sure until you add them all up. We will have to skip some things like going backwards. Like if I said one of the interior angles is 162, could you go backwards and stuff? And there are some other tricks, but unfortunately, we don't have the time. Or could you figure out all the angles in here? Yes, it can be done. But let's check this one out. Sometimes, remember, they'll throw some algebra at you. They'll just say this plus this plus this. And you go, let's see, well, it's a 180. I guess I'll do some algebra here. I'd write x plus 1 plus x plus 2 plus x minus 6 is 180, and I could solve for x. But make sure you answer the question carefully. What is x? Okay, so I would see here, and so I would put this together, do a little algebra. X, x, x. I see that's 3x, 1, 3, minus 6. That's 3x minus 3 is 180. I'll add the 3. So 3x is 183. Divide by 3, and I get x is 61. Now you can't just go, yay, I'm done. But look at the questions we need to answer. So we got x is 61, but let's says angle A. Plug it in. Are you sure it works? Plug your 61 into each one of these. As you'll see this on the test, you'll have to go, so what is angle A? What is angle B? What is angle C? And you go, let's see, this is 61 plus 1. That's 62. So I'd say angle A is 62. B, I'll put in 61 minus 6. And I go, let's see, that's 55. And then I got to put it here, 61 plus 2. That's 63. And do these add up to 180? Make sure you check. If they do, then it works. And yes, they do. It's kind of hard to read here, but yes, that adds up to 180. So sometimes I'll say, what is the x? But actually, what is each angle? Yeah. So we can give you some algebra. Skip ahead. And here's some more. What about this one here? That's a straight line. What's a straight? Oh yeah, straight line's also 180. And I could say, well, so this and this make a straight line. And it's Cartman. It makes a straight line there, and I could say that's 180. So this plus this is 180. And I could say, well, x and x, 2x plus 40 is 180. And once again, I could finish and do the algebra. I'll scroll this down a little bit. Let's see, 2x, subtract the 40. That's hard to read. 140. X is 70. But don't just stop and go, yay, I'm done. How do you know you're right? Plug it in. Put that there and here. This side would be this angle here, which does look smaller, should be the smaller number, 70. Over here, this is 70 plus 40, 110. Do 110 and 70 make 180? Yes, they do. All right. So we could do all types of puzzles. And here's some, they can get even fancier. And you're like, well, I could figure out, this all adds up to 180. After I figure out x, I could go, well, then these two add to 180, and I could figure out y. Or here, I know these two are the same. Okay, but I don't know what they are. But I do know that these make 180 a straight line. Or these two make a corner. Are you sure it's a corner? Well, this is a corner. This is 90, so this is 90. And so I could work my way through all types of drawings. So what about this? Do you think you can do this one? Let me pause for a moment. Okay, so after you've paused, hopefully you fill these in. What do you think? What do I know? Not much. Oh, wait a minute. This side is the same as this side. That means this is isosceles. That means this angle is the same as this angle. And I don't know what they are, but they're both the same. Wait a minute. Here's a triangle. That's 180. 180 minus 20 leaves me with 160. So here's 20 degrees. There's 160 left, and it's split into these two spots. So 160 split into 2 is 80. So this must be 80, and this must be 80. That works. Now what could I do? Pause if you want. Oh, here's a straight line. Right here's a straight line. And 80 and 100 make 180. So keep looking for triangles and straight lines. So there's 180. Now I can kind of do what? Oh, wait a minute. Someone said that this is the same as this. So I have another isosceles triangle. That means this angle matches this. And here's a triangle. So 180 take off 100 leaves me with 80, and we'll split it again. 40 and 40. And hey, I could go out here. There's the butterfly, the vertical angles. This angle, the same as this angle. So this is the same as this. So this is 40. Hey, here's a straight line. So this is 140. And this is 140 because they're vertical. Getting the idea? Sorry for the mess. Okay. And likewise, here's some more. What would I do? What about these? Did these add up to 180? No, wait a minute. These are the same. Or this angle is the same as this angle. And this problem, I would say these are equal because, oh, those are vertical. I would go 5x plus 20 equals 7x plus 14. And then I would go ahead and solve for x. And after I get my answer, I'd plug it in just to make sure I have the same answer. So in this one, these are equal to each other. But here, these add up to 180. So you have to pay attention. This one and this one makes a straight line. They add to 180. Solve for x. After you get your answer, you plug it in to see if it works. But remember, this is equal to this. They don't add to 180. So each one of these can be solved. So let's give you some work to do. All right, so your homework is to do the practice test. This is some matching. And there's some stuff here. There's a photo. You figure out the missing angles. Here's some algebra. Remember, do they add up to 180 or are they equal to each other? Solve for x and then plug in x. I say, what is angle ABC? Now, to understand what angle ABC is, we haven't talked about that. Find letters A, B, and C. A, B, C. That must be this angle over here. That must be, I'm gonna mark ABC angle. That's a shortcut for angle. A to B to C. That's this right here. That's this angle here. Because if I just said angle B, you'd be like, this angle B, this angle B, this angle B. So angle A, B, and C. The B will be in the middle of the angle that B is in the middle of and includes A and C. So it means tell me what this angle is. So solve for x, then plug it in and see what that is. And plug it in here too, just to see if you get the same answer. Like if you think x is 1, if you put 1 here and 1 here, you won't get the same answer. In fact, 4 times, you'd get a negative answer. Something would definitely be wrong. And same here. Are these the same? No, but what do they add up to? Straight line. So each one of these can be done. Sometimes you have to cover, find the straight lines. And here's a neat one. This is a neat mystery, but you see the parallel markings? And you see these parallel markings? Maybe you could find a big triangle Ooh. Or maybe another big triangle. Ooh, right there. Kind of hidden. It's like find the hidden things, like where's Waldo? Or maybe you can find some vertical angles. These two are the, I don't know. Here's some verticals, but no, I don't know them. Here's some verticals. Here, ooh, here's some verticals. Maybe look for the Z's. What, the Z's? Well, if you got something parallel, you could go like, I wonder what E is the same with. The Z, E would go with this one. Well, I don't know that one. Here's another Z right there. So B goes with that. Oh, I don't know that one. Or do I know that one? And of course, look for little triangles. You can do a reverse Z too. You can kind of, you go the other way with the Z. You can even do kind of an inside outish Z. Try to get a different color. Like you could kind of go, I don't see a good one to do on here, but sometimes your Z could be funny, but it has to be parallel lines. There might even be some more Z's, okay? Like, I don't know, we'd have to find one, okay? Right in there. What, that's a Z? Yeah, because that is parallel to that. Okay, so it's kind of fun to do. Remember this? And this all says like, every angle here is the same. What does each one measure up to? And you can go 360 around. That's kind of a hard one. Tells me it's a rectangle. What do you know about the corners? Look for Z's, look for verticals. A regular hexagon, everything's the same here. Can you figure it out? So your homework is to do this, take a photo of it and submit it. And some of you discovered you can actually write on the screen in Canvas, and then they just submit what you wrote on the screen in Canvas. And you never have to print it or anything. So just write on the screen or write your answers or print it or somehow do some type of submission. Have fun.